Hello students, I Anjali Sharma in association with Infinity Learn by Sri Chaitanya Group is going to present today's topic, and that is EM waves from the chapter Structure of Atom. EM waves means electromagnetic waves. So in today's video we will be covering three major topics. At first we will be covering about the wave nature of light, and then we will be discussing about EM waves. What are these and how are these produced? And number 3, properties of EM waves, which is a very important topic in your classes. So let's just start our video without any delay with the wave nature of light. So as you all know from your previous classes that sound travels in the form of a wave. In a very similar manner, various phenomena such as reflection of light and refraction of light have also proved that light is also a wave. And by the theory of C. Huygens in his theory has proved that light is an electromagnetic wave. Yes, you heard it right. Light is considered as an electromagnetic wave according to the wave theory proposed by C. Huygens. So, what are these electromagnetic waves and how are these produced? At first, you should know that an electromagnetic wave or the electromagnetic waves are produced when an electric charge vibrates, that is, it moves back and forth about its main position. Here, electro word represents to electric field, whereas magnetic represents the magnetic field. So electromagnetic word in itself is describing its meaning, a wave that has both electric as well as magnetic component perpendicular to each other and also to the direction of propagation of the wave. So, electromagnetic wave can be described as a wave in which both the fields, that is, the electric field and the magnetic field, are perpendicular to each other and also to the direction in which the wave is moving. It is clear in the given diagram that there are three axes x, y, and z. X is the direction in which the waves are propagating. This is the traveling direction. Along the y-axis there is electric field, and along the z-axis there is magnetic field. So we know that all the three axes, that is the x-axis, y-axis, and z-axis, all these are perpendicular to one another. If x is the direction of propagation of the wave, along the x-axis the wave is propagating, the wave is moving, then along the y-axis there is the electric field, and along the z-axis there is the magnetic field. Means all the three things, the traveling direction, the electric field, and the magnetic field, all three are mutually perpendicular to one another. That's what we mean by an electromagnetic wave, that along the three axes x, y, and z, which are perpendicular to each other. In the very similar manner, these three factors, that is the direction of propagation, the electric field, and the magnetic field, are also mutually perpendicular to one another. Point to be noted here is visible light is an electromagnetic wave, and the speed of light is 3 into 10 raised to power 8 meter per second. This is very important to remember, that light moves with a constant speed, which is denoted by a letter c, and the value is 3 into 10 raised to power 8 meter per second. Another important property of EM waves is that they do not require any material medium for their propagation. Electromagnetic wave travels in the form of crest and troughs. If this is the crest 1, this is the crest 2, this is trough 1, and this is trough 2. Then what is the distance between the two adjacent crests, or distance between two adjacent troughs, is known as? The distance between two adjacent crests and two adjacent troughs is known as wavelength.
wavelength denoted with lambda. If we consider a point x, then the total number of waves passing through at that point in 1 second, the total number of waves passing through that point x in 1 second will denote its frequency, and frequency is written with f. Now, if we have to establish the relation between the two, lambda, that is wavelength, it is inversely related to frequency. The relationship between wavelength and frequency is the inverse relation. Now, when we remove the proportionality sign and replace it with equal, then a constant is introduced, and constant here is c. So our formula becomes c equals to lambda f, that is c, which is the speed of light or the speed of the em wave. It is the product of its wavelength and frequency. This relationship is very, very, very important, and you all should mark this into your notebooks. So that was all for today's video. Now we will meet in our next video with some more important concepts. So till then, take care of yourself, and we will now meet in our next video. Thank you for watching. Take care everyone. Bye bye.